Hi guys, I'm doing a belated follow-up video to my pocket watch case project. So as I mentioned before, this is a project I began several months ago to create an off-the-shelf standardized 18 size pocket watch case that would replace cases that have been scrapped or which are no longer serviceable due to wear. So what I'm going to do in this video is I'm going to show you the 3D model I had printed several months ago, which I did an unboxing video on. So I'll show you the different components. I will explain the changes to the design that I have made since I received this model. And then I will show you my progress in manufacturing a prototype case. So I've actually made quite a lot of progress. I bought an old CNC lathe, which if you follow me on Instagram, you will have seen. And I've got some brass stock, and I have been creating a mid case. So the key component around which the case will be built. So I will show you where I'm at with that, and I will demonstrate the process of setting up the CNC lathe, and I'm even going to try to videotape me cutting threads. So stay tuned. So as I believe I explained in my previous video, there's a real dearth of pocket watch cases due to scrapping and also just due to wear. As you may know, for American watches, most watch movements and cases were sold separately. This isn't always true. There were some cases produced from the factory. But in many cases, what you would do is select a pocket watch movement and also the case, and the jeweler who sold you the watch would mate those together for you. And that would allow you to incorporate some personalization in the case, some engraving or choosing a design that you found attractive. So because the watch and the case were typically sold separately, it's no great sin against history to try to create a pocket watch case that fills that gap in the market and tries to give all these old movements that are floating around out there a home. So like I said, I'm trying to create an off-the-shelf 18 size pocket watch case that in external appearance closely approximates an original case. So here I've got a classic American 18 size base metal case, and one that closely approximates this external appearance, but which incorporates some reasonable updates like dust and water resistance and a limited amount of shock proofing. So what I have here is the 3D model that I've had printed. I'll just move this center. So as you can see, in external appearance, this closely approximates the old case. The external dimensions are the same. So the width of the case, the width of the bow, the width of the crown, the dimensions of the crown, bow, stem. In all these respects, the case closely approximates the old case. Here you can see that the old case sits a little bit taller, and that's due to the fact that this one has a closed case back, whereas with the updated case, I've included an open case back. So the case consists of, and not all components are here, it consists of a mid case, front and back bezels, which are not identical, and I'll explain the reason for that shortly. A tube or a pendant, a crown, a bow, a sleeve and a stem, which I have not tried to 3D model. I'm trying to keep this from falling apart on me because I've just friction fit it together. So those are the components of what you might call the original case. In addition, I have included this ring, which I hope to make out of silicone rubber to give a little bit of shock proofing to the watch. Of course, these watches are old, they're not shock proofed, and that means that they're really susceptible to balance staff damage, even with pretty slight knocks. So what I'm trying to do here is not insulate it from all shocks, but insulate it from a small amount of shocks. So, perhaps it wouldn't insulate your watch against a 6-foot fall, but maybe against an 8 or 10 inch drop on a table. That's what I'm going for here. So I have created this ring to match the external profile of 18 size pocket watch movement. I've used a Waltham movement to give me my external dimensions. The external dimensions are not all the same, even though at their widest point, they're almost always pretty close between Waltham, Elgin, Illinois, Rockford, whatever. At their narrowest point, that is on the top plate, they do differ in dimension, in width. So I may have to make more than one of these rings to accommodate them. But the idea is that this component, the case itself, does not vary, and these minor differences in width can be accommodated with different sizes of ring, and that the ring should go between the watch movement and the case and give a small amount of protection. So I've designed the profile of this both to fit the dimensions of the movement and also to hold the watch securely in the case while giving some kind of shock protection. Turning to the changes I've made to the design since I made this 3D model, this was actually a really effective exercise because I could put this up against an old case and just look at it and see, does it look right? And actually, my feeling was that this didn't really look right in a number of respects. So first of all, let's just look at the side profile. So as you can see with the original case, there is a curvature between the mid case and the bezels. And if I just turn my case on its side and you line them up, you can see that the curvature is really not the same. This is not a good approximation of the original case. This one has, I'd say, much more of a gentle dome to it, whereas here you can see that my bezels fall away quite rapidly from the mid case. So this is a change that I have incorporated in the design, and I'm going to show you on Fusion 360 in a few minutes what the current state of the design is. You can see also that the shape of the crown is not quite right. This onion crown is much less pointy than the one that I designed, so I've changed the shape of that. You can see also that the dimension of the bow, the diameter of the bow is quite a bit bigger, so I've slightly reduced that, and I've also changed the length of the what I'm going to call the tube, what most people call the pendant, a little bit. So those are some of the key dimensional changes that I've made based on this 3D printed prototype. One additional thing that I've changed is that these original cases have this fluting or knurling in the bezel, both the front and back bezel, and the reason, of course, is that it gives you grip on the case to unscrew the bezels, and so what I want to do is, because I'm going for dust and water resistance, I want the user to be able to torque down the front and back bezels. And to that end, I thought I'm going to include some kind of fluting on the front and back bezels, for which I could create a key that would allow the user to torque them in place. But there are a couple considerations about this. One is the difficulty of manufacturing a suitable key and expecting people to have the equipment to use that key to torque the bezels down. I don't think that's realistic. It also just doesn't look quite right to me. This fluting is really fine, and the reason I think for that is there is no key for this, right? It's just to give you friction with your fingers so that you can turn the bezels down. So I tried to make the fluting a little bigger, thinking I could manufacture a key. But I think it just doesn't look right. It looks too kind of unwieldy. It also kind of risks emulating a certain watch brand that I think we can all easily think of, that is well known for its fluted bezels. And I don't want to be seen as impersonating someone else. So what I've done in the updated design is I have actually included a ring of spherical holes or catches, which I'll show you, in which you could insert a JAXA tool. So the point is that without much equipment, you could hold the case in a case vise on a table and use a standard JAXA style or import or Chinese JAXA tool, imitation JAXA tool, to an inexpensive one to torque down the bezel. So I want to make that easy for people because I don't want people to rely on some kind of specialist to be able to open and close the watch case. I'm really someone who believes in the right to repair, the right to tinker as you see fit. And to that end, I want to have an easy way to open and close the watch case while torquing it sufficiently to make it dust and water resistant. So that's another change that I've made. So what I'm going to do now is give you a very brief overview of the computer-aided design and manufacturing process. This is Fusion 360. It's a software with a free version with basically all the functionality of the paid version. So before you're making revenue, you can use this program to design your product and figure out how to manufacture it. Here's the pocket watch case. As you can see, it incorporates many of the design changes that I talked about before to make the case more closely approximate a traditional 18 size case. So there you can see the profile is much more appropriate. If you look from the front or back, you can see that the bow diameter, external diameter, is much closer to what you would expect. Um, and generally, I think that I have done a good job in preserving the external appearance of a traditional pocket watch case. The other change that I talked about is using drilled holes instead of a fluted profile to torque the bezel down. So I've got to finalize the dimensions on that. You can see that from the outside, the case looks identical front and back because I've included a transparent case back. However, there are front and back bezels. The front and back bezels are not the same, and that's necessitated by um, the profile of these watch movements and creating the spacer ring that I've talked about. So front and back bezels are not the same, although they look the same from the outside. Likewise, the mid case has a front and a back. Because you're designing components in Fusion and then fitting them together, you can then remove them to take a look and inspect each component. I'm not going to go into great depth about this because I've worked hard on creating this design and I don't want to give away every single aspect of it before I've had a chance to manufacture a prototype. But for example, you can see I cut out for a lever set watch, and you can also see here a groove for an O-ring to ensure water and dust resistance. So I can put the bezel back on there. So that's a rough overview of my design, and will give you a taste of what the final product is going to look like. I'll show you also very briefly the manufacturing tab. Fusion is great because it allows you to both design and design a component and also determine the steps that you're going to take to manufacture it. So what I'm doing here is creating the steps to make the mid case. This is the component I'm working on now. So you start with some piece of stock, the dimensions of which you decide, and then you create operations, lathe machining operations in order to cut out the piece. And this is a trial and error process. I'm not a machinist. I'm learning as I go. So this has been challenging, but also interesting. So the manufacturing tab has a tool library. If you need to, you can create your own tools. So these are lathe cutters, like what you would buy. So this, for example, is a right-handed cutter using a specific kind of carbide insert that correspond exactly to the cutter that I have on my lathe. So using this tool, this particular right-handed cutter, one thing that I am going to do is cut out the profile of the case. So if I just take a top view here, let's turn it around. You can see the rough profile of the case, and you can also see the tool path. So the cutter is going to come in and take brass off the stock in order to create the external profile of the case. And you can even simulate how this is going to go. So if I press simulate here, I can run this, and you'll see how the cutter is going to take material off the case. Now this makes it really, really easy with Fusion. It's not foolproof. You may miss some key fault and end up ruining the part, but at least what you can do is hopefully get a sense of exactly what the lathe is going to do, even if it doesn't always work out that way in practice. So there we go. That's a very rough overview of the design and manufacturing tabs. in Fusion, and hopefully that gives you a nice little taste of what is to come. So let's turn now to the lathe. This is a CNC lathe, which I found for a reasonable price here in Toronto. It is, I think, a teaching lathe, so it would have been used in a college back in the late 80s or early 90s. It weighs about 170 pounds. The length of the bed is maybe 15 or 18 inches, and the spindle height above the bed is maybe 4.5 inches, 5 inches. So it's really the perfect dimensions to work on this 18 size case. The 18 size case is, as I'll show you, just about the maximum you could do. But what's nice about this lathe is that someone has upgraded the hardware, so the circuit board or whatever you want to call it. I'm not a computer person, to be able to use a modern laptop and a USB cable to take code that is output by Fusion, which I've shown you, and use the laptop plus some free software, Universal Gcode Sender, to send it to the lathe and make cuts on the workpiece, which you can see in the chuck there. Looking a little bit closer, here's the chuck. This is really quite a cheap, this is like an $80 chuck that someone has bought off Amazon. It's pretty bad, but actually I can work with this as long as I make adjustments to keep the workpiece true, and I'll show you how I do that. Here's the carriage and cross slide. There you can see the stepper motor to move that. It has a tool post, which is aftermarket, but this is quite a good quick change tool post of a British style. And it's got a tailstock with a Morse taper, so you can use a Morse taper chuck to drill. I've done that a little bit with some success. So I've had to make one change to the lathe, one modification, which I can't say I'm hugely proud of, which is I had to reduce the height of the cross slide, that is, grind it off about 5 millimeters to get me sufficient clearance under this stock. So I can't say I'm hugely proud of this, but in terms of the pedigree of the lathe, it's not a huge deal. This is not some fancy Shablin lathe, and it has to do what it has to do. So given that it doesn't compromise the function of the lathe, I have to forgive myself for doing that. So that's an overview of the lathe. Here it displays RPMs. Here you can see the load. This is actually quite a handy feature. If you're making too heavy a cut, you can get some indication of this. Spindle RPM control. So one limitation of this lathe is that the spindle is operated separately, is operated manually, basically. So whatever RPM you tell it to do in the G code, it's not going to do. You have to manually set the spindle speed, and that is potentially going to be a problem when it comes to cutting threads. We're going to see. Although I think I have pretty good control to be able to set RPM, and start and stop buttons, which do nothing because the hardware of the lathe has been updated. So like I said, I've got quite a cheap 3-jaw chuck here. The problem with this chuck is that it doesn't control runout very well, so it has difficulty keeping the workpiece, or rather setting the workpiece concentric to the spindle. But that's really important, because if your stock is not concentric, or not, if it's running out a lot, then you may have to take a lot of material off the stock in order to get a true or a round workpiece. So in order to get a workpiece or a part that's dimensionally accurate, you want to get your stock to have as little run out from the spindle as possible. So what I have here is just a really cheap dial indicator, which is basically just a micrometer. This one measures hundredths of a millimeter. And so you can see as I rotate the workpiece, the total run out is maybe 7 or 8 hundredths of a millimeter. And that's not terrific, but it's not too bad. I have enough excess diameter in my stock here that I can reduce it to get a part that is round, that is like true to the spindle, but also dimensionally accurate. And just by watching YouTube videos, I've been able to reduce the run out to this, acceptable level. So as you can see, sorry, I just wanted to focus here. As I turn, you can see the workpiece is not totally concentric, but what I can do is I can basically just loosen the chuck and then knock the stock with a rubber mallet to get it as true as possible. If I get it under 1/10 of a millimeter, that's basically acceptable for me, and I can work with that. So obviously you only want to do this once in the setup because you cannot reposition the work once it is in progress. You would have to start all over again if you have to reduce it more than you want to get a round part. So I'm working with what I got here. This is a cheap chuck, but I don't want to replace it because these things are really very expensive to get a nice one. But I've been able to get reasonable results so far just with this pretty crude method. Okay, let's just talk about the stock and the choice of materials. So here I have 2 1/4 inch brass stock. I ordered a foot and I've cut off 3-inch sections in order to make my case prototype. So the mid case and also the front and back bezels. I've got stock of different diameter, of course, to make the tube / pendant, crown, etc. Let's just talk about the choice of material. So brass is really easy to machine, and this lathe does not have a huge amount of horsepower. So given that, brass is a good choice, at least for the case prototype. I haven't made a decision, if I'm actually going to produce these serially and sell them, which is something I would like to do, what material I should go with. Brass is certainly a traditional material in watchmaking, but of course tends to tarnish, which is why traditionally it's plated with gold. I think there may be some way around that, like using a brass sealer, like you would with a musical instrument, in order to preserve the appearance. But I haven't made a final decision about that. In any case, for the purposes of the prototype, it's great because it's easy to machine, doesn't take a lot of power. So that's what I've gone with. Here you can see the mid case in progress, which I'll go over again in greater detail in a minute. Okay guys, this video is running a bit long and I still haven't received the cutter I need to make the thread cutting that I want to show you guys. So I'm going to end this video here. Let's call it part 1, and I'll pick it up in a few days, maybe a week, knowing me, maybe a bit longer, with thread cutting and showing you exactly how far I've got with the case. Okay, thanks. See you soon.